Hi folks, this is Steve Ray. I'd like to talk to you about our week 1 lecture, which is basically an introduction or overview of project management and the course in general. Tonight we'll introduce a number of topics that we'll cover in more detail as the course goes on, so this will just be sort of a warm-up and way to whet your appetite for some of the things that are yet to come. So here's the course in a nutshell. Basically what we're going to talk about tonight is what do we mean when we say a project? And why would we bother to study this subject called project management? It's better when we start to study any topic, it's good to establish context, the reason why it's important. Otherwise, obviously, you would have many other choices to spend your time studying. So why don't we establish why project management itself is something that it's worth devoting a 14 or 15-week course to. We'll talk a bit about the characteristics of traditional project management. As you may remember from the syllabus walkthrough, this is more or less the quote-unquote PMI style of project management, where PMI stands for Project Management Institute, and their famous document, the PMBOK, the Project Management Body of Knowledge, talks a lot about the conventions of traditional structured project management. After we speak to that a little bit, we'll talk about this notion of the agile term, which is, 10 to 15 years ago, you could date it a number of different ways, maybe 20 years ago, a number of folks in the industry saw that traditional software project management techniques were not working particularly well, and they wanted to try some new things. And those new things included methods like Scrum and Kanban, and also to a lesser extent Lean, which is sort of a more philosophical take on certain software development topics. So throughout tonight's lecture, we'll spend some time talking about traditional project management, and then we'll try to characterize what's different about Agile, and then talk about the Agile methods you see there. And of course, as the weeks pass, as we discussed when we did the syllabus walkthrough, we'll certainly go into each of these topics in more detail. So what do we mean when we say a project? So the canonical definition from PMI's PMBOK, again, that's Project Management Institute, Project Management Body of Knowledge. The first is a group or organization. The second part, the PMBOK, is basically a particular book they publish, if you will, a very dry book. They say it's a temporary endeavor undertaken to create a unique product or service. So let's focus on a couple of words there. Temporary basically means that a project has a defined start and end. It's not just endlessly ongoing work. That's operations work. Operations work is something that we would more or less like it to continue roughly the same way forever, or until we change our business practice, whatever that is. So a project is set apart from operations work in that it essentially has a defined start and end date, and we want the world to be different when the project is done. If business models never changed, an organization might like to operate in more or less the same way indefinitely, just because change tends to be expensive sometimes. So if a particular way of business or way of operations were working out for them, they might be motivated never to change it at all. But projects by definition are temporary. And we say create a unique product or service. We're trying to differentiate it from the idea that, in a manufacturing organization, you might create 1,000 of the same kind of laptops in a day, or whatever a reasonable production schedule might be. When we do a project, we're looking for a unique outcome. If we're trying to replicate an outcome that has been previously achieved and we just want to make more of them, again, that's more of an operations function, a manufacturing function. So a temporary endeavor that creates a unique product might be like we're trying to design a new piece of software. To copy that software endlessly is obviously sort of a trivial operation relative to the original definition and development of it. So why would we bother to study project management? All of us have probably been in a math course at some point, and as the teacher turned to some topic that was a little bit frustrating, it's the quadratic equation, it's learning differentiation and integration in calculus, whatever the subject might be, at a certain point, a student in the class who becomes frustrated with it asks the teacher in exasperation, how am I ever going to use this? What am I going to do with it? And of course, the universal math teacher answer is, in case you want to become a math teacher. That was never a very satisfying answer for me. So, whenever we undertake any area of study, I like to try and lay out in advance why would we bother with this? What is the practical significance of us learning something about it? Why would we study it? What do we expect to get out of it? And there are a lot of good reasons to study project management in particular. One way to think of project management is just how do we get complicated things done? We all know how to do simple things. It's kind of easy to go to the store and buy milk. It's easy to write an email to your friend, the boss, etc. It's typically very, very large activities that seem overwhelming to us. How do we re-engineer a product line? How do we build a new complex web application that has previously not existed? Or even a relatively simple web application? Like something like that has many more moving parts and tasks than many things we do in everyday life. And so when we think about, these efforts that are going to take multiple people to finish them and weeks or months or years potentially to get things done, it becomes more challenging to figure out just how to go about doing that. So project management is effectively an art slash science of how we get large important things done, things that are sort of overwhelming in their scope, complexity, the number of resources required, etc. Project management techniques help us essentially break it down into manageable chunks and track those chunks to completion. A good way to think about projects is, even though the term project might connote we're building a new piece of software or some major organizational change, you could think of nearly anything as a project. This notion of it's a temporary endeavor and it creates some unique result, that could apply to so many different things. It could be planning a birthday party for a coworker, could be building a completely new line of business, it could be building a new product, etc. So once you start to look at things through the lens of project management, you'll see that it applies to a very wide variety of activities in the organization. Again, operations is a bit of a different story, but even in the realm of operations proper, you'll probably find improvement initiatives and such that you can conceive of as projects. So many, many different activities in an organization could be construed as projects, at least potentially. One other thing to note about project management is that when we say we're doing good project management, that's almost synonymous with doing good management in general. So if you have aspirations to a technical leadership role or other leadership role within an organization, studying project management is great training, if only because a lot of project management concepts are applicable to management in general. Making plans, tracking things, breaking down work, assigning it, dealing with risks, and those kinds of things. So project management training is probably the best formal structured training that I know of that helps you prepare for management tasks in general. And last one, I'd say many of you or most of you have strong technical skills or else you wouldn't be in this program. So how do you differentiate yourself from the many other software developers or network engineers, etc., who may be coming out of similar programs like yours and might have similar technical backgrounds? I'm sure you're very good at what you do, but it's nice to have capabilities in the arena of something like project management because that makes you more than a developer or database administrator or whatever it is that you aspire to be or like to do when you're not in school. A skill set like project management makes you much, much more valuable and multidimensional to an organization. I love it on my teams when we have technical leadership that also can do project leadership and people leadership. Those are great things to be able to combine. So this course is going to focus, as it says at the bottom of the slide there, mainly on software projects. In particular, that's because the Agile techniques we'll cover in the second half of the course are almost explicitly devoted to software projects. It's not that you couldn't use the principles for other things, but those techniques were born with software development initiatives in mind, and they're very heavily slanted towards those initiatives. With that having been said, the lessons are broadly applicable. And in the first part of the course, the way we'll talk about traditional project management is applicable to almost any kinds of projects. And of course, software projects and other things like construction, etc., may differ a little bit, but a lot of their core is going to be very much the same in traditional project management. So the lessons we glean from this course that are most directly related to software project management can also be applied to many other things, including your home life if you want to do that. If you wanted to move, let's say, from one apartment to another, one home to another, etc., you could very easily think of that as a project and break it down and schedule it and execute it using the techniques we cover in this course. So hopefully some of you are familiar with a report called the Chaos Report. And it came out a long, long time ago. Let's say the initial one came out a long, long time ago, and it's, I believe, published almost every year. I'm not sure if it's still being published, but let's say for 20 years after the original 1995 report, the Standish Group has published this report, this Chaos Report, on a regular basis. And it's basically a state of the software industry type report. The punchline of the report is supposed to be, wow, we're terrible at managing software. So the 1995 report came out with some startling statistics that said, only 16% of software projects succeed. And when we say succeed, we mean something like they meet their targets for scope, roughly what we're going to deliver, schedule, roughly how long it's going to take us to deliver, and budget, how much money we're going to spend to do so. So that was a pretty dire figure. When it came out, it made a lot of headlines. 16%, basically 1 in 6 software projects succeed, the rest fail. And in later reports, the numbers have become a little bit less dire. They've brought the numbers around to, or the claims that roughly 40% of software projects are succeeding rather than the original 16. Of course, those are still terrible numbers, right? If you fail materially on any of those major areas, schedule, scope, and budget, more than half the time, you're not performing particularly well. A lot of people, including myself, are fairly skeptical of the Standish Group's chaos report and other gloom and doom predictions that come out of the software engineering industry. Personally, I think the Standish Group, this consultancy, exaggerated a number of things in order to drum up consulting business, and the chaos report was intended to be shocking, which I think is probably largely a sales vehicle for them. But whether the number is 16% or 40%, most people would agree that there's quite a lot of failure in the software world, that we're still not particularly good at going through a software project and delivering what we said we would deliver when we said we would deliver it and for the cost we had initially spec'd out. So even though some people question these chaos report findings and think the numbers are a little bit, let's say, pessimistic relative to reality, still many people would agree that the state of the software industry is pretty difficult right now in terms of its success rates. And some people think agile techniques are helping there, so we'll talk about that as the course goes on a bit. So here's another look that's a little bit less dire than what we saw from the chaos report, but is still not too dissimilar. And that is Dr. Dobbs used to be a development magazine, so to speak. It was called Dr. Dobbs Journal. It was popular for a while. It became more or less a website, and I think it's kind of fading out right now. But they used to do this survey on a regular basis, and they would ask about project success rates. And here you can see, as it says paradigm on the left-hand side, what method we're using, traditional at the bottom, and then iterative methods, agile and lean. Those are Agile is typically an iterative type approach. So, you might wonder a little bit about the semantics of those different categories, but nonetheless, you get a basic flavor of what they're talking about there. Like if you think of Scrum type things having, according to the Dr. Dobbs survey, 64 or 65% success, and then traditional project management still down like in the 1 out of 2 range being successful. So what does this mean, successful, challenged, and failed? So here's how Dr. Dobbs was defining them. Successful means basically we hit pretty close to what we thought on cost, schedule, and scope. And remember, scope is basically something like I built the thing that I intended to build or something very much like it. Challenged means, hey, at least on one of those areas, cost, schedule, or scope, we were pretty far away from what we said. And then failed is, yeah, the team was really not able to bring it together and deliver any sort of solution at all. So these results are, not as, certainly nowhere near as bad as the chaos report results are suggested to be, but you can obviously see that there's still plenty of room for improvement. If only 65% of agile projects are successful and 1 out of 2 traditional projects are successful, the industry has a long way to go. And the failed rates, just to point it out, for the agile methods, remember down back here we see that the agile methods, lean, agile, and iterative, have relatively low failed rates. They basically mean that the project wasn't canceled before delivering something useful. Part of what we'll cover in this course is the idea that the agile projects aspire to work usually in small chunks and deliver something sooner rather than later so that it can be critiqued and be the source of feedback and it can be iterated upon to deliver other things in the future. So just wanted to point out that if the definition of failed is the organization wasn't able to deliver a solution at all, as it says on this slide, then we would expect pretty low failures for agile projects because agile projects try to deliver something sooner rather than later. So traditional projects that have kind of more of a big bang approach where they try to give you everything at once, or let's say at least in larger chunks, we would expect a higher failure rate, just at least based on the definition here of, failed means that nothing was ever delivered. So just wanted to point that out, that the meaning of failed might be a little bit different between traditional and agile projects in addition to the success rate. Okay, so let's draw some distinctions between project work and operations work. We already started to talk about this some minutes ago, but as the PMI definition said, a project is a temporary and unique type of thing. As we said earlier, operations, generally the goal is to make Wednesday look like Tuesday and Tuesday look like Monday. Ideally, operations folks would have the same thing happening every day, every hour, every month, etc., just because that's predictable, repeatable, there's no drama in it. They would be well staffed to handle that. They would have playbooks to handle that sort of thing. If each day looked like the day prior, rarely would we have operations issues that sometimes make operations a little bit too exciting in both many organizations. And notice that, between the projects and operations, there's a tension between what each of them is trying to achieve. Like, for example, projects are inherently disruptive. The idea is, as we said earlier, to create a unique product or service, something that doesn't exist before or hadn't existed before. Operations would prefer to have stability. Again, it's more predictable. It would mean that they're not getting curveballs and surprises, that they know how to handle the things they see, etc. So the upheaval implied by projects is a challenging thing, and an organization can be upset by it. An organization will need to adjust to the kinds of changes that come about because of project work. So we can't have too much of that. We can't have too much instability and constant change, and yet we can't have too much stability because that means we're stagnating, that we're not keeping up with our competition, that we're not evolving our organization and our product offerings in important ways. So there's this inherent tension between what the project-oriented folks, i.e. the kinds of people we're going to act like in this course, a tension between what they're trying to do and what operations folks are trying to do. And again, it's something around stability, how much are we trying to change the environment we're in versus make the environment we're in predictable, running smoothly, and relatively undramatic. So if we're going to be talking about projects, what sorts of things make a project successful? One of the things we're going to do throughout this course, particularly when we talk about traditional project management techniques, is we're going to look at case studies. And the case studies are going to tell us how different projects have fared. And unfortunately or not, many of the case studies are going to focus on project failures because it's a little bit more interesting to read about a particular project that went awry and why it went awry so that we don't replicate the same mistakes. So we're going to see a fair amount of emphasis in the case studies that we'll be reading on things that made projects fail. And then from that, we can sort of infer what kinds of things are likely to make projects succeed. And here are a few success factors that are going to come up a lot. First is agreement, and by that I mean agreement about what the project is supposed to achieve. If it seems to you that that ought to be the most simple and obvious thing in the world, That's a very understandable position. But please recognize that in an enormous number of organizations, there is great disagreement about what projects are supposed to achieve, and projects can go on for months or even years without the key stakeholders aligning on what they're supposed to achieve. It's a concern that'll come up time and time again in our discussions. Projects are likely to be successful if we have a plan. We need to know what we actually have to do, who's going to do it, and a way to see if it's getting done. If we have a plan and we assign it to people and then we have really no good way to check or verify that it's progressing as we like, we're probably going to have a nasty surprise when we come time to deliver whatever it is we had promised to deliver. Communication. Communication is probably one great reason that many projects fail. Um, there's an old rule of thumb that says something along the lines of 80% of project management work is communication. And in the Fast Forward MBA and Project Management book that we talked about when we did the syllabus review, there's a great quote that says, every technique in this book is a communication technique. I think that's probably a little overstated, but it's roughly right. It's directionally correct that you could look at the very practice of project management as just communicating much better among a group of people and communicating in structured ways. There are aspects of project management that don't really fall into that description, but it's really, really not a bad way to look at the profession and to look at what it means to be successful as a project manager to make sure that information flows appropriately. Controlled scope is an important success factor. Many projects have sort of lived or died based on how well people were able to constrain all the different things they were trying to do in the project. You may have heard of the term scope creep or experienced it yourself, where a project that began trying to achieve a certain limited set of aims over time starts to collect additional requirements because people see opportunities to get things done that haven't been done for years or haven't been done to their liking, and they try to heave additional things on top of the project cart, so to speak, and it gets weighed down and the axle breaks because there's only a certain amount of change and a certain amount of work that a project can absorb at one time. And if we try to do too much in the course of the project, especially things that are low priority, we're probably going to bog down the other things and hurt our ability to deliver the most important things that we need to deliver. And the last thing we'll want to talk about is management support. Only small projects have a chance of succeeding without meaningful management support. Anytime it is going to be a long effort involving multiple departments or many people, if you don't have management support behind it, eventually the project is going to be cannibalized. People are going to lose the will to continue on with it. When I say cannibalized, I mean the people and other resources are going to be taken off the project and devoted to other things. So in a typical organization, there are many, many different projects we could be pursuing at one time. Projects that do not have management support, some high-level person or influential person saying that this is something that's important to them, those projects are likely to die just because there are other things trying to eat up time, and those things are going to be championed and defended by somebody in the organization. So I don't know if my operations brethren would agree with this, but you could say that project work brings a number of challenges that at least aren't present in operations. And not that operations doesn't have its own challenges, but I think you could make a strong case that project type work is a little bit more complex, a bit riskier, and sometimes more difficult to pull off than operations work. But we can have plenty of debate about that. But what sorts of challenges would we have with project work relative to operations work? One is that the personnel we have to work with are just much more variable. They're coming and going. If we have different phases and the project's devoted to different things, we might only need a certain person for a month or two. And the kind of roles that we need in the beginning, let's say maybe we need heavy system administration roles to set certain development and test environments up in the beginning of the project, those things are a little bit less important as the systems get commissioned and used on a regular basis by the project staff, and the folks who had initially done the admin work to set them up, they'll sort of fade more into the background over time. So, whereas operations again tries to repeat on Wednesday what it did on Tuesday for the most part, project work assumes essentially that you're going to have a rotating cast of characters because we're trying to create these unique and temporary endeavors. the people we need from day to day, week to week, month to month, etc., are going to change. Project estimates are generally hard to do. Like if you have a good rhythm going in an operations shop, you'll have a pretty good idea of how many tickets you can close a day or how many customers you're going to serve, etc. Because over time, statistical norms for these things arise. And so it's fairly easy to estimate things like what my customer traffic is going to be on a given day, those sorts of things. Estimates of building new stuff are much harder to do. And if you've tried to estimate software development work or any kind of technical work that's really not something you've done before, I'm sure you've seen or have experienced horror stories of things taking 4 times longer than they were supposed to, or 10 times longer than they were supposed to in extreme cases. Those kinds of mismatches between the original estimate and what actually happened are not at all uncommon in the software world. That's why we have things like the chaos report in Dr. Jobs' journal saying that there are plenty of project misses out there. So I think generally because we're building new things and there's less precedent for the work we're doing, project-oriented work, things like software projects, are a bit harder to estimate than operations work. Sometimes in project work, the authority under which the project is being done is a bit unclear. Um, the well, often to make a project work in these temporary events or temporary dedications of resources, they're not really the org structure. We'll typically have an organization structure in place. And when I say org structure, like who reports to who, who's manager, those kinds of things. The org structure tends to be relatively stable over time, and the project work tends to shift around a bit. An engineer who worked on something in March might work on something different in April. They'll still have the same organizational structure they're part of, but they'll be bouncing around to different projects and working with different people on those projects. So because of the somewhat dynamic nature of project teams and that they're often cobbled together from different parts of a broader organizational structure, the lines of authority are sometimes unclear. Like if two people from two different departments come together and the only place they get unified in the management chain is several levels up from both of them, it's sort of hard to know who's in charge and who has the most authority and what the role of the project manager is. And can the project manager tell me to do things, or do they have to ask politely and maybe I'll do them? Those kinds of issues with unclear authority are just very common in project work and something that we're going to need to try and overcome. And the last challenge, at least described on the slide here, is um, where again we said operations has a certain cycle and rhythm to it, where there are daily quotas, weekly quotas, monthly quotas, etc. There's some statistical predictability, at least in most operation shops, where we can say, hey, this is roughly what we expect to do this Tuesday because we did something pretty similar last Tuesday. And of course, there are things like seasonality and other factors that might change operations from day to day, but for the most part, if you've done it for a little while, you have a pretty good base experience and set of mechanisms for predicting what's about to come in the future. Projects generally not so much, right? Because they follow different time intervals. Building one application is harder or easier than building another application. It's not like every application is going to take you 3 months or 6 months or 9 months or even 1 month. Different things are going to have different needs, and the time intervals associated with them are going to be much more irregular. As we said, the cast of characters, the personnel supporting it are much more irregular, etc. So it's kind of difficult to establish the same statistical rhythm and the same day-to-day understanding as we can in the operations world. Here's just one simplistic depiction of why software is harder. This is a picture of the Philadelphia skyline. It doesn't contain either of the Comcast towers, which are the tallest buildings right now, but this is Liberty 1 and Liberty 2. In Philadelphia, Liberty 1 was actually sort of one of the first modern skyscrapers built in Philadelphia in quite some time. You may know some history of Philadelphia, but there was a time where you were, by law in Philadelphia, you could not have a building that was taller than the top of Philadelphia City Hall. And at the top of Philadelphia City Hall, there's a statue of a historical figure named Billy Penn. And if you've ever been in the city, you see Billy Penn standing on top of Philadelphia City Hall and he's looking out over the city. But for quite a long time, up into the 1980s, there was a law that said no building in Philadelphia could reach higher than Billy Penn's hat. And then at a certain point, they realized that was holding the city back. So they repealed the law, and the first two towers to go up after that, at least in my recollection, were these Liberty Towers. And again, you see Liberty 1, the first one to be built on the left, and Liberty 2, the second one to be built on the right. And obviously, they're different buildings, but they're kind of the same architecturally. And if I were the project manager for Liberty 2, the one on the right, the first thing I would have tried to get my hands on is the project plan for Liberty 1. Again, a structurally very, very similar building. And of course, they're different, and I'm sure that uh, there were new technologies incorporated into Liberty 2 and new environmentally friendly standards, et cetera, et cetera. But for the most part, if you had a project plan for Liberty 1, it would be very, very instructive for trying to construct something like Liberty 2 because they're, again, pretty close in terms of the sort of building you're building. You're using the glass and steel probably in similar proportions. The architecture, throughout the building and especially on top is pretty similar, etc. Software is harder because when we have to do something like this, when we would try to, let's say, if we had the metaphorical equivalent of a piece of software that was Liberty One, and then we wanted to recreate it with some slight modifications, rather than rebuilding the building from scratch, we would just make a digital copy. We would effectively Control C Liberty One and then Control V to create Liberty Two, and then we'd make some changes to it. Obviously, like the point here basically is in the real world, like for construction projects, for example, we are going to create replicas sometimes of objects that have previously existed and or built, in this case, buildings. Liberty 2 is largely a replica of an existing building, and we had lots of lessons learned from constructing that existing building. In the software world, copying something physically, digitally is a trivial operation, right? It's Control C, Control V. So when I say software is harder, it's because we're always doing something new. If it's worth being a project, like Control C, Control V is not a project for us. It's something that we do trivially. So something that isn't just copying and creating a new instance of something else has by definition more unknowns to it, more things to figure out, etc. So in the construction industry and other places, they might try to replicate things they've done before pretty exactly, and it still might take them 6, 12, 18, 24 months, whatever it is, to make that replica. In our world, in the software engineering world, replicas are easy. We just Control C, Control V, or use whatever digital copy mechanism we want. The point is that when we bother to do something that's a quote unquote project, it means we don't really know how to do it yet. If we knew how to do it, we would just, make a copy of something that existed previously. So it's often why software estimation is a more challenging thing because there's typically more novelty in it than there would be in other disciplines. If we want to do a straight copy of something, that's trivial and it's not a project to us. Okay. So let's talk a little bit about traditional project management. As we said earlier, traditional project management is, in many people's eyes, aligned with this organization called PMI, the Project Management Institute. They have headquarters here in the United States, actually not far from Villanova, just right down the Blue Route or Route 252 in a town called Newtown Square. And they have a credential that's put out for project managers called the Project Management Professional Certification. Did my PMP many, many years ago. It's a sort of, I consider it a valuable exercise. About half of it was valuable, and half of it was kind of studying fluffy things that PMI just wanted you to study. But if you're interested in pursuing the project management professional certification at any point, I can give you some suggestions and guidance about that. This course actually will prepare you for it to some extent, but it's not intended to be a prep course that would allow you to get your PMP certification right afterwards. So you often hear this kind of project management described as waterfall style management. And waterfall is a bad word in certain circles. I don't think it's a bad word, but many people do. I think that the situation determines what technique you're going to use, and in some cases, a quote unquote traditional waterfall approach works very well, and in other cases, the more agile technique is going to work very well. But the PMI style of project management is very, very closely associated with this notion of waterfall management. And by waterfall, we mean something like there's a kind of linear cascade from requirements gathering to analysis to design to construction of software to testing and actual deployment. It's kind of assumed that there is a well-defined sequence of activities, and we typically only move one direction forward in that sequence with minimal iteration or loops built back into it. And that's a contrast to agile methods, as we'll talk about a little bit later. In traditional project management, there's a heavy emphasis on detailed plans and comparing what we actually did to the detailed plans that we might have made days, weeks, or months prior to actually executing the work. So traditional project management is often associated with a fair amount of upfront planning and attempts to reconcile reality to the plan, either by making the reality go faster in most cases or by actually changing the plan, rebaselining to match what seems to be happening on the ground. If you have ever been inundated with requests for status reports, you'll love traditional project management type topics because um, it, that kind of management style is often associated with people collecting status reports. And did you were supposed to get task 1, 2, 3 done today? Did you actually get task 1, 2, 3 done today, etc.? So traditional project management has heavy status report type focus. As I alluded to, I think a few minutes ago, uh, traditional project management has something of a bad name right now. A number of people think it's outmoded, that Agile has basically totally supplanted it, that we shouldn't bother with traditional project management techniques anymore. So, if you study or are interested in traditional project management techniques, some people will look at you as though you're a dinosaur. I don't think that's entirely justified. As I might have mentioned in the syllabus walkthrough, I have used both traditional and agile techniques to very good effect, and I think there are certain characteristics of a project, like well understood domain, low user interface content, if it's primarily a backend system, etc. Those kinds of things, in my opinion, lend themselves in many cases a little bit more towards a traditional project management style, as do, let's say, a maintenance releases of an existing piece of software are often managed as with traditional project management techniques, even if the group doing the maintenance won't really admit that. But it is not in style today to do much with traditional project management. I think some of that is deserved because traditional project management is an awful way to build certain kinds of software. And so it deserves to have gotten a black eye over the years for many mistakes and shortcomings associated with traditional project management, but it still has plenty of uses. And that's one of the reasons this particular course is half traditional project management and half agile project management from a software development perspective, because I think both sides of that divide have a lot to teach us. To give you a flavor of how dry and boring some of the things PMI puts out are, here is a commonly referenced chart. If you are studying for your PMP exam, you would expect to spend a fair amount of time trying to almost memorize things like this. But we'll come to this a little bit more later throughout the course. But essentially, this is a grid defined by PMI Project Management Institute that has knowledge areas on the left-hand side, and these are sort of cross-cutting concerns that can come up at many different points of a project, like communications, dealing with risk, etc. And then across the top, you have process groups. And those are more or less time-phased kinds of things that you go through as you go through a project. So initiating, how do I start out and figure out what I'm supposed to be doing? I spend a lot of time creating plans. You'll see how many things show up in the planning column in this particular diagram. And I'll actually go do work according to the plan. I'll have to execute according to the plan. And then I monitor and control. I make sure that my work is progressing and I compare it to the plan I originally made and see if I have to make adjustments to either the work I'm doing or my original plan to bring those two things a bit closer together. And then closing is, of course, finalizing the project. I archive documentation. I make sure that everyone recognizes that it's been done or agrees that we have achieved our original objectives, etc. So PMI, especially after the world has made sort of an agile turn, PMI likes to insist that it never intended that the process groups would have to be sequential. Yeah, but you can clearly see based on how they're named and conceptualized. The initial thought was that initiation happens first, then planning happens, then executing, then monitoring, controlling, then closing. And of course, there might be some overlap between those phases, like towards the tail end of planning, we might begin executing. But for the most part, it's pretty obvious from the way PMI has structured things that this is a little bit of a sequential or linear approach to project management. So anyway, not that any of this is necessarily wrong or right, but it gives you some idea of how PMI has seen the world for a while, and how they have this notion of a fairly like a largely linear process of getting a project completed, and then these sort of cross-cutting concerns like cost, quality, communications, etc., that come up at many different points through the phases of that life cycle. So in just a description of the different process groups that were across the top there, initiating, I think you could say a fair synopsis of it is, should we bother doing this? Like the thing we're talking about doing, what do we really mean by it, and is it worth our time? Then in the planning phase, we kind of get into, okay, well, if we accept the high level goal from the initiating part, well, what are we doing specifically? Like, what do we do this week, next week, etc.? What is Tom going to do tomorrow, or what is Susan going to do on Wednesday? Those kinds of things are going to come out in the planning phase, where we try to take, um, the things that led us to initiate the project in the first place, and refine and articulate those more, so that we're able to understand them and move forward better in a concrete way. Then executing is, of course, the do it part, where we try to complete the work and the plans that we've developed. And then under monitoring and controlling, we're watching the work that we're doing, we're comparing it to what we had originally forecasted, and we're seeing, are there gaps? Why are there gaps? Is there any way that I can fix the gaps? And again, that might be we rebaseline the project and go with a different schedule than we originally thought, or it could be something like we just need to make the tasks that we're doing faster, so we're going to have more project managers beating on more people and trying to get them to cross the finish line sooner. And of course, at the closing, we finalize things and we make sure that we're really done and that we've kind of left the campsite the way we found it, or better than we found it, if you will. We put things back, etc. We make sure that any activities that need to be done to put the project really, really to rest are completed. I won't read through all these for you. You can do this, at your leisure. But here's again a look at the knowledge areas, and we have things like scope management that would say, am I kind of building the right stuff? Am I building what is needed? And am I sending the team to work on the right kinds of things? Time management, of course, is schedule oriented. When do we need to have this done? Are we on track to have this done by that time, etc.? And there are similar considerations that, again, I won't read off the slide to you guys for every one, but cost, quality, etc., all of them, there's kind of a set of questions that we could ask, and that these are things that cut across those somewhat time phase process groups that look kind of like a life cycle from beginning to end. Things like human resources management and communication management, they come in at various points in that life cycle. It's not something we can confine to one or two of the phases. So this is just pure opinion from me, take it or leave it. But a question that often arises when we're talking about project managers is, does the project manager need to be technical? Like, do you need to know how to code to be a project manager for a software development project? Or do you need to just know how to give assignments and follow up on assignments and break down work? Typical management fare. So I guess the question essentially is a project manager more of a manager, or on a technical project, are they more of a technical person? So this is the way I see it. Project management as a discipline is really not at all domain specific. The things that we're going to cover in the first half of the course, kind of generic project management techniques that are often applied to software but could be applied to a number of things. The project management has plenty of, or the discipline of project management has plenty of internal content that can be applied to a variety of different domains. Again, whether it's software, building cars, soliciting charitable donations, whatever it is. The management itself is not domain specific. However, in my experience, the project manager, the person who fills that role, really ought to be. And by that I mean if it's a software development project, the project manager should know something about developing software, even if they're not doing software development, and even if project management as a discipline is not really domain specific, it doesn't necessarily theoretically require technical knowledge to work on a technical project. I find that the most effective project managers do have considerable technical background related to whatever the project is focusing on. And why is that helpful? Largely for communication. Remember we said earlier 80% of project management could be conservatively estimated as communication type work. And if the project manager doesn't understand what different groups are saying, if things have to be explained to the project manager in tedious detail, if the project manager who's often seeing different facets of the project, if the project manager can't recognize that Group A is thinking about something in a fundamentally different way than Group B, and that they're going to have a conflict when they try to bring their different pieces of the solution together, that's a challenge. So the most effective project managers I've ever worked with have all been have all had a fair amount of domain specific knowledge in technology or whatever the particular area that they were working in is. Doesn't mean that you need to have domain specific knowledge to do project management, but you will be more effective in the role of project manager if you do have, some close working familiarity with the kinds of skills and activities that your project is based on. So we can't go too far in any discussion of project management without talking about this notion of the iron triangle. And the iron triangle basically says we can think of different parameters of a project using a triangle. And on one leg of the triangles, there's the notion of like, how much are we spending or what resources are we bringing to bear to make this project happen? One of the other legs is, well, how long is it going to take us? How much time do we need to invest? And then towards the bottom there is, and of course we could draw any of these legs on any different spot. It's kind of arbitrary that anything's on the bottom versus top, but on the bottom of this particular diagram is the notion of what we built. So we kind of have the idea of what are we building, what feature sets to what degree of quality, how much does it cost us to build those things, and how long does it take us to build those things. So the iron triangle basically says you get to pick any two. If you try to, get a specific scope and quality at a specific cost, you're not going to be able to set the schedule at the same time. Or if you want to set a certain schedule and you want to set like a threshold on the costs you're willing to spend, then you can't also constrain the scope and quality. You kind of pick any two, and then the third one has to be left to vary freely a bit because obviously, things that you might do if you want a something done very fast with minimal resources applied to it, you're probably going to get a crappy product. I mean, we've all seen that. And again, if you want a good product, if you want to constrain the scope, but you don't really want to invest a lot of resources in it, maybe there's only one person who can work on it, that person's probably going to take a long time to build a quality product. So you can't, if you constrain, it's going to be good work, and you constrain that we're going to have one resource on it, you can't really dictate top down how long it's going to take. So, the point of the iron triangle is just sort of to enforce to us the idea that we need to make trade-offs. We need to choose which parts of the triangle are most important for a particular effort. So we have to consult our stakeholders and say, is time to market the most important thing here, or is a broad feature set the most important thing here? Or do we have to keep development costs under a certain amount of money, or the company will go bankrupt? And we'll kind of figure those things out. And remembering that we can only constrain at most two of those things at a time, we'll try to work within the stakeholder needs and the stakeholder desires to deliver what is required. But there's one way you can kind of cheat on the iron triangle, and that is to sacrifice the people. So they're in my view sort of a hidden chunk of the triangle. So what if we did want really good quality and we weren't willing to pay for more than 3 resources? And those 3 resources told me that it's going to take 10 weeks to get this done, but I would really like to constrain the schedule and make it 6 or 7 in order to meet a certain launch date, get it done in time for the Christmas season, have it demoable in time for a certain conference, etc. If I really do have all three constraints I want to enforce at the same time, one way I can try to do that is say something like, well, we have to get it done in X number of weeks, so you people are just going to have to work weekends, 70, 80 hours a week until it gets done. I have worked in organizations where that was attempted, where there was really a hard deadline and they needed something or believed they needed something done quickly, and they essentially squeezed the little guy you see on the screen here. They squeezed the people working on the project in ways that were unhealthy, in ways that made people angry, for caused them to want to quit, etc. So remember this iron triangle, and you might think at times that you could sort of cheat the rules of the iron triangle by putting more pressure on the people on the project, but rarely does that work out very well. So we've talked a lot about traditional project management, and what do we mean when we say agile project management? Forgive me if you can hear my cat is yelling in the background. He's getting older and he likes to meow. Um, Agile project management is sort of based, I want to say, more or less on humility. The idea that, if traditional project management tried to create these long-ranging detailed plans, we often found that those plans didn't match reality. And once we were weeks or months into the project, we could barely recognize the plans anymore relative to what we had actually lived through. So the belief in agile project management is essentially that we don't know as much as we once thought we did. When we build these elaborate long-range plans, they tend to be inaccurate, they tend to fall apart, and we have to invest or waste extra time kind of rebuilding the plans, only to have them in turn yet be wrong yet again once we're 2 or 3 weeks down the road. So Agile project management generally tries to stay away from long-range detailed planning of the kind you might see in traditional project management a lot. And instead, the philosophy is pretty different. The philosophy of Agile project management generally is we're going to work in small chunks. We're only going to do, we're going to plan for a week of development at a time, or 2 weeks of development at a time, or we're going to plan to work on just 3 requirements right now. And by working in small chunks, hopefully we have better visibility of the work that's currently in front of us. If we have to plan a project that's going to take 2 years to complete, it's pretty hard to come up with a high fidelity plan that's going to be accurate at the end of, you know, 2 months, let alone 2 years. However, if we're working in smaller chunks and we say something like we're going to plan the next 2 weeks, we have a much better chance of actually planning out what's going to happen in those 2 weeks. And, for me and for a number of other people, 2 weeks often seemed like a good planning horizon. 1 week's a little bit too short. You feel like you're cheating and that you could extend a little bit beyond that. But in many organizations, including every organization I've ever worked for, it's kind of hard to see beyond 2 weeks in some ways. Obviously, you need to have some notion of what's going to happen quarter by quarter, year by year, etc. But that's kind of a high level fuzzy notion at most places. And working in small chunks tends to match most people's experience of how far they can actually see down the line and how far ahead they can reasonably estimate work that they might do. Another emphasis of Agile project management is things are going to change all the time. So, the traditional project management makes it's focused on heavy planning up front, and the philosophical assumption there is, change is going to be a relative rarity. Like if we thought things were going to change all the time, we wouldn't make elaborate plans up front. To make elaborate plans up front assumes that things are going to change rarely in relatively small ways, and when they do change, we'll deal with it. We'll adjust the plan, etc. But traditional project management doesn't really think that you're likely to need to adjust the plan very much. Agile takes a totally different philosophy and basically says we expect lots of change. So we're going to just build all of our methodologies around the idea that the thing we thought we were going to do 3 weeks ago is probably going to end up looking pretty different today. So agile methods are essentially not only, they're not trying to accommodate change as an exception process, which is traditionally what traditional project management does. Agile project management techniques, Scrum, Kanban, etc., more or less assume that change is coming and say, how can we build a framework around the assumption that things are going to change rapidly? And then Agile project management also emphasizes learning and adaptation, and this kind of goes hand in hand with the idea of these short cycle times or working in small chunks that we have. If we work in small chunks and we complete something small and get feedback on it, we have a greater opportunity to learn faster and adapt our processes, our understanding, our skills, etc., better to the task at hand because we see things that went wrong. Our customer tells us, no, that's not the way it's supposed to be, and we make small adjustments along the way. So there's a lot to be said about the philosophical differences between traditional and agile project management, but I really personally think you know I think the key difference is basically how far do you think you can see with fidelity? And traditional project management folks or people who are trying to use traditional project management, their assumption has to be, their philosophical commitment has to be, I think I can see pretty far with a good degree of fidelity. And the Agile project management philosophical commitments are very different. They're something along the lines of, I don't think I can see very far, so I'm going to just work for as far as I can see very clearly. I'll get some feedback and then I'll plan out my next set of work in a similarly small chunk. So just different ways of looking at the world and different commitments about what is reasonable and likely. Here's the Agile Manifesto. You may have heard of it before, but it's essentially a statement that some founders of the Agile movement came together and wrote up this document, and I believe it's at agilemanifesto.org, or you could just Google it and you'd certainly get to the website very easily. And it's essentially a pretty terse statement of what the Agile movement values. The idea that individuals and interactions are more important than processes and tools. You have to remember the Agile Manifesto was written in the late 90s, and this is after a number of heavyweight software methods were being used without great success. There's a company called Rational that IBM ended up buying. They had something called the Rational Unified Process, and they had this kind of elaborate tool suite associated with it. When I was with the Department of Defense, we bought it and tried to use it, etc. And the founders of the Agile movement, the Agile Manifesto, they basically thought this isn't working very well. We're so tied up with processes and tools that we forget things like software teams are made up of people who need to work effectively together, and customers we need to please should be our first focus. So the Agile Manifesto, as it says there, emphasizes individuals and interactions over sort of the more formal mechanical processes and tooling that became popular in the 1980s and early 1990s. Working software over comprehensive documentation, the idea that that documentation that we spec out up front um, is unlikely to match the software we actually build, and software changes a lot, so if we document the you-know-what out of it, then our documentation is often just going to become stale and old. So the Agile Manifesto likes to privilege the idea of working software being the thing that we focus on. If you want documentation of how it should be, point to the software. The software is going to be evolving and updated in real time. When the customer points at it and says, I don't like it, then we change the software quickly, show it back to the customer, and that changed software that now aligns with what the customer wants, that's our documentation. We're more concerned about making the software itself be its own authoritative statement rather than building a bunch of plans, making sure those plans are correct, at least in somebody's eyes, and then building software to match the plan. We say the software is the manifestation of the plan. Let's focus on the software. I won't delve into these too much because I think the lecture is getting a little bit long here, but traditional project management was very much about people signing things and trying to project that they would do a certain amount of work within a certain amount of time for a certain amount of money, or they would end up getting, undercharged, overcharged, etc. So the Agile Manifesto tries to privilege the idea that we're going to collaborate with our customers and rather creating these contracts and these sort of detailed, you agree to this, I agree to that type documents, which are mainly so that we can't hurt each other too badly. Let's try to build up the trust and just, explain to the customer we can't quite see as far as we used to. So we're going to collaborate, we're going to build iteratively, and we're going to get in a good direction. But as we sit here in, let's say it's August or September 2018, I can't tell you with fidelity what I'm going to be able to deliver by July of 2019. Although I hope that by July of 2019 we have a new season of Game of Thrones because it's been a long time coming for that. And then last goal of the Agile Manifesto, at least highlighted here, is rather than following a plan, we're just going to be able to respond to change. And that's something we talked about a few slides before. We more or less assume in Agile techniques our philosophical commitment is to say that The world is going to change a lot. Requirements are going to change a lot. We're going to learn new things about the technology we're trying to implement, and our customers are going to change their minds based on being able to see prototypes of the software, etc. And that's okay. When the customer changes their mind, that's not a bad thing. We're getting closer to the truth, the reality, etc. So our method has to be able to respond to change rather than construct a rigid plan that's difficult and cumbersome to update, etc., and keep updating over time as the plan and the reality diverge. And note that the Agile Manifesto founders are not saying that there's no value in the red stuff, the stuff on the right. They just think that it's probably best used more sparingly than their predecessors had used it, and they like to focus more on the things on the left. And I think there's probably a lot of wisdom in that position. So we talked a little bit about Agile philosophies. Let's talk about concrete Agile methods. Scrum is the method that most people have heard of. If they've heard of Agile, they've probably heard of Scrum. For many people, their understanding of what Agile is in a concrete sense is almost completely informed by Scrum. Scrum is far and away the most practiced quote unquote Agile technique. When I say practiced, I mean most widely practiced. And again, it's sort of the standard bearer of what Agile means in many people's minds. So Scrum is pretty simple. Um, at least conceptually, it's simple. It's one of those things that's, it's sort of easy to think you understand at a brochure level, but it's fairly hard to do well. And I would say that I have rarely to never seen a team across, 15-ish years of working with agile teams in one capacity or another. Rarely have I seen a team that I thought was doing this well. Most people who claim to be doing Scrum are doing it kind of badly. And that's one of the things we'll talk about in the second half of the course, what makes bad Scrum versus good Scrum, etc. And Scrum focuses on this notion of a sprint. So there's kind of this short, repeated cycles of effort. Generally, they're 1 to 4 weeks long. Organizations kind of pick what works for them. I think statistically, the 2 week sprint is the most common that I've seen personally. I don't know of any industry statistics on this kind of thing. But the idea would be we come up with a sprint length. Let's say it's 2 weeks. And in that time, we're going to go through an iteration of our product and we're going to pick a certain number of features that we can actually complete in 2 weeks. We're going to add them to the product. We're going to show our customers, and then we're going to do it all again. So we're going to spend, as we said in the syllabus lecture video, we're going to spend about 3 weeks covering Scrum in all of its forms and all of its different ceremonies and requirements, etc. I say all of it. It's actually not a terribly complex framework, but this is Scrum in a nutshell. So we have a role called product owner, and that person is, and it's supposed to be a single person, is empowered to make decisions about a software product and what it's supposed to do. The product owner knows what is important from a business perspective, and they're supposed to be representative of, what the end users would, how the end users would like to see a product work, how they'd like to see it function. So the product owner is going to help us put together a set of requirements. And we typically refer to those requirements in Scrum as user stories, but if the term user story doesn't mean anything to you right now, just substitute requirement for the time being. We'll talk a lot about user stories in the second half of the course. So we have this list of user stories, and they make up kind of a backlog of things, work that we'd like to complete. And we refer to that as our product backlog. And we'd like that sort of ordered so that things near the top of the backlog are kind of the most important things we would work on next. And we would probably spend a little extra time making sure those things are better defined, let's say, than something we don't expect to work on for 6 months to a year. We can leave those things a little bit fuzzier. Remember we said that we work in these 1 to 4 week sprints. So at the beginning of each sprint, we have a sprint planning meeting, and we take items out of the product backlog. Remember, the product backlog is something like, let's pretend our product is a web application. The product backlog would be something like a list of all the different features and changes we'd like to make to the web application. And then in the planning meeting for each sprint, we pick some subset of that product backlog and make it our sprint backlog, which is to say the set of user stories or the set of requirements that we hope to deliver by the end of that particular sprint. And once we pick our set of stories, our set of requirements, we kind of break them down into more granular things. Like if we wanted to add a new feature to a website that was something like, I don't know, directions to stores, we would probably have to put together some backend services, maybe a persistence layer. We'd have to do UI work. We'd have to glue all that stuff together with controllers, etc. So there would be kind of a technical task breakout associated with any of those user story level or those requirement level functionalities that we'd like to deliver. We could break each of them down into a set of technical tasks that might be pursued by different people in the team. So we end up meeting every day, throughout that 1 to 4 week sprint. We do a so-called daily scrum meeting, and it's just the team gets together for hopefully about 15 minutes, answers a few questions that I won't go into here about, how do things, well, the questions are basic, so I will go to them. The questions are generally thought to be something along the lines of, what did you do yesterday? What are you going to do today? Do you have any obstacles or things that are slowing you down? And we'll talk a little bit more about how to run those kinds of sessions effectively later on. But every day the team gets together and reviews kind of what happened, what's supposed to happen right now. Hey, does anybody need any help with anything? And they proceed from there. And so that daily check-in is supposed to kind of enforce that the team is going in a good direction and surface any problems the team might encounter sooner rather than later. So after the team has kind of gone through, let's say it's a 2 week sprint and they've done their sprint planning and they have a sprint backlog to work on and they're doing daily scrum meetings, etc. At the end of the 2 week sprint, they should have some chunk of finished work. They've added some features to the web application to follow on with the example we used earlier. So at the end of that time frame, they're going to conduct a sprint review, which is they're going to go to the product owner and say, hey, product owner, this is what we built for you. What do you think? And the product owner is going to give them a thumbs up, thumbs down, or give them some criticism, etc., that they can, if the product owner wants changes made to it, those become new things that are put in the product backlog and they get pulled maybe into the next sprint and maybe not. And that's based largely on product owner prioritization. And then after that, we have a sprint retrospective. Whereas the sprint review is supposed to focus on the product we're building, the sprint retrospective is supposed to focus on the process. How are we doing our work? What things do we need to do better? Like just an example might be, hey, we keep pulling user stories or requirements into the sprint, and we don't have test data that allows us to test them. I was in this position in Comcast a number of times where because we had a service-oriented architecture and many different system dependencies, we'd have to sort of pre-stage the data for certain test scenarios in our test billing system. And that was kind of a cumbersome process to do. So a number of cases we ran into where we tried to do some work in a sprint, but we actually didn't have the test data that would be appropriate to it loaded in the billing system yet, and so we couldn't really effectively complete the requirement. So noticing that pattern, we sort of like that's the kind of thing you would talk about in a sprint retrospective. Hey, here's the way we're working. This is how I think it could be improved, etc. And then the team would come up with some plan to address that. In the case of the example I just gave you, we would essentially try to prep the test data a bit before we thought that that requirement would be pulled into a sprint. It was likely to be pulled into a sprint. And so when it actually got pulled into one of the sprints, we had already started the process of getting the test data. So it wasn't as cumbersome. We were actually able to complete testing for the features by the time the sprints ended for the most part. One thing I'll point out about the team, the product owner is really the only special role. Well, I shouldn't say that. There's a role called the Scrum Master up here, and the role of the Scrum Master, loosely speaking, is to kind of enforce the Scrum process, make sure that it's working smoothly, and help out the team by removing any impediments to them getting their work done. So the Scrum Master kind of owns the successful execution of Scrum as a mechanism or method and helps the team, remove obstacles that are often non-technical in nature. The product owner is the final arbiter of what the product should be doing, how it should behave, and what are the most important things to work on. And then everybody else is the team. And you notice there's not like a separate dev team and test team. It's just the team. The development team is supposed to work with the product owner and the Scrum Master to get capabilities out. So we'll have more to say about the characteristics of a good team in the second half of the course. Kanban is a bit of a different approach. It's kind of it doesn't use these fixed cycle times that Scrum does for sprints. It's a so-called flow-based approach. So the idea is you'll have some equivalent of what I called a user story when we were talking about Scrum, and you want to make each individual user story flow through your development process as fast as you possibly can. So Kanban would love to be, the ideal Kanban team is kind of just moving things through their process, whatever that is, at a pretty consistent rate. They know that if a new requirement comes in, they can probably move it from conception to execution 12 days or 5 days or 4 days or whatever it is, because they have history of kind of running it through their process. As it says here, work in progress limits, they tend to focus on a small number of things at a time, just so those things can get sufficient attention, and again, so that they can be moved through the process quickly. Kanban is really just, when I say all about cycle time, it is largely about cycle time. There's an obsessive focus on how can we be faster in moving things through our pipeline. We want to work on them efficiently, get them completed, ship them, and then pull new things into our pipeline rather than have a number of things that we're juggling all at one time. Because it doesn't really have the same iterative character as Scrum, and because there's this notion of, a quick um, move through a certain life cycle, or how quickly we can move a particular software requirement through phases, Kanban is sometimes being criticized as waterfall-like. The Kanban folks don't particularly like that, but I think there's a little bit of merit to that criticism. Personally, again, I don't think waterfall is a bad thing, but for those people who think Kanban is waterfall-like, I think there's something to that. So Kanban development teams will often work around a board that looks something like this, and one of your project artifacts that you're going to prepare later in the term is to actually go create a virtual board like this, or maybe a physical one even if you want to. And you can see across the top of the Kanban board here, there are phases, if you will. There's kind of like a holding pen for things we're going to work on next, a space for things that are being analyzed, a space for things that are being developed, and a place for things that are being tested in some way, and then presumably user acceptance here, and then actually going out to production. And you can see sort of individual stories or requirements that in each of these parts of the phase diagram. There are work in progress limits set up here, and this one basically says we're not going to have more than 3 things in analysis at a time, no more than 3 in development at a time, no more than 2 in acceptance testing at a time. And we get a little bit deeper in the term, we'll go over the rationale for those things, for having work in progress limits, etc. But generally, it's intended to allow the team to focus and kind of move more quickly. And when we get to the assignment of you guys putting together a Kanban board, I'll talk to you more about how teams use color coding and what sorts of things they reflect on these story cards, etc. Okay. And then we'll finish up tonight, because this is getting a little bit long, but we'll finish this up with just a quick discussion of lean software principles. So as I've said a few times, the lean principles have kind of found their way into other methods. So, you'll see lean software principles show up in Kanban in particular, and there'll be some sort of interesting parallels between what the lean folks say and what we try to do in Kanban. But lean is also an entity in its own right. On the spectrum of things, like Scrum is relatively prescriptive in terms of methodology, Kanban's a little bit less prescriptive, and then lean is kind of more philosophical in character. It's really not prescriptive at all in terms of concrete practices. So lean wants us to do things like eliminate waste. Well, what does that mean? It means things like, if we're gold plating software by adding in a bunch of features that the users haven't asked for yet, but we think they might need, or we think would be cool for them to have, that's probably wasted work. If we have a feature that's developed and just sitting around for months, but it, has not yet gone to testing and then out to production, that's considered waste. And if something has kind of sat around, it didn't need to be done as soon as it was, and we could have done something more effective in that time, something that had a better shot to go directly out to production, etc. So waste in general is something that the lean folks are going to focus on. And by the way, many of these ideas are sort of drawn from lean manufacturing concepts, which were the inspiration for them. You may have read about companies like Toyota that have very, very efficient, well-tuned manufacturing systems over time. So lean, to some extent, is an attempt to appropriate the ideas from very efficient manufacturing organizations like Toyota and bring them into software development. Now, whether it's a good thing that software development looks for its metaphors in manufacturing world, where they try to create the same thing again and again, I wonder if that's a good idea. But nonetheless, a lot of people have found lean principles interesting. Some of the others are, you know, like amplify learning. I don't know is terribly lean specific, but they like to emphasize that one of the ways you amplify learning is get stuff done quickly and get a little bit of feedback on it so that you can iterate over it and do it again and again. Lean does not have sprints defined per se, but the idea that you would do things like iterate and learn quickly from it is very consistent with what we'd expect from lean. Lean wants us to decide things as late as we responsibly can, and that's because early decisions are often wasteful. New information comes up, or maybe the world changes and you never actually had to make those decisions or commitments at all. As we said a few times, lean, like Kanban is very lean inspired, and lean tries to move things through a pipeline quickly to deliver as quickly as the team reasonably can. Lots of reasons for that we'll kind of go into when we talk about lean as a standalone unit in the course. But think about things like a requirements rot. If something sits around for a while, its requirements are likely to change, and maybe we wrote development work for nothing. So if we deliver as fast as possible, hopefully we bring business value into the organization and we minimize that rot dynamic that I just described. Lean folks love to talk about empowered teams that are not being micromanaged, teams that sort of build quality in from the get-go, and that teams try to look at things in a holistic manner. So, hope those last few things are hopefully good for any software development methodology, but they are sort of preoccupations or very strong interests with the lean teams. All right, that's everything that I had for the first week. I don't actually know how long this is, so I'm going to cut this video off and see how long it ended up being. But again, I'm sorry I couldn't be there in person. I hope this discussion or this overview of some of the topics that we'll be talking about in the course is helpful. And of course, as we go through the weeks and months to come, we'll have the opportunity to explore each of these areas in greater detail. So I'm going to put up also some readings for under the week 2 slides and readings. There'll be some lecture slides there, and there'll also be some case studies to look at. I think I mentioned earlier tonight that one of the ways that we're going to learn about traditional project management is to read some case studies that talk about project management failures. So please, in addition to doing the textbook readings, for that Fast Forward MBA in project management, I'd like you to look at the articles I'm going to post on the week 2 slides and readings, because we're going to discuss those during class next Thursday night. All right, folks, thanks very much for your time, and I will see you in about a week. Thanks.